Welcome to the Mizzou Asphalt Pavement and Innovation Laboratory. My name is Professor Bill Butler from Civil Engineering. Glad to show you around. I bet you hate those nasty potholes that you hit, especially like when the spring breakup occurs. Well, our lab is here to try to mitigate those potholes and make asphalt more sustainable and more durable and more economical for our infrastructure. Punya here is working on some asphalt testing, getting a asphalt binder specimen ready to go. So as we move into the middle portion of our laboratory, I want to tell you a little bit about that first bit of testing, and that is on the asphalt binder. And so we have several machines that we can do that with. First of all, liquid asphalt binder comes from crude petroleum. It's refined, and it comes in harder grades and softer grades. And we can put all sorts of additives in it, like this polymer that you see here, styrene, butadiene, styrene. So we might want to test at low temperature to get the viscoelastic properties in a bending beam rheometer. We may want to test at high temperatures in shear, and we have a dynamic shear rheometer, a simple basic unit here for our industry characterization following SuperPave, as shown on the chart here, or the advanced characterization where we go to extreme high temperatures or low temperatures. That can be done on this Anton Par unit. We can also test suspensions like asphalt plus rubber. Speaking of asphalt plus rubber, we can grind up tires from cars and from trucks, and we can put that in asphalt. It lowers the cost. It improves the durability, makes it a lot more sustainable. Speaking of sustainability, we can use things like roofing shingles or RAS, reclaimed asphalt shingles, RAP, reclaimed asphalt pavement. And more recently, we've been trying to help with the waste plastic problem, and we've partnered with Dow Chemical to put plastic, like you see in this bottle here, into road infrastructure like asphalt materials. Let's move over to the next portion of the lab. Here we can do tests on the asphalt mixture, and one of the tests that we're really famous for is the DCT, or disc-shaped compact tension fracture test. It drives a crack across the asphalt. And if we can do that in the lab and measure something fundamental like fracture energy, we can translate that energy into what's happening out on the roadway to avoid those cracks from happening in the first place. You can see some of the integration of testing and modeling we do here on the screen. And so we have a lot of our group meetings in here, and we'll dole over our computer simulations that we do outside of the lab, really in our computer laboratories. So that's another part of our integrated approach to innovation. Our innovation has led to patents, and so we've got a placard here that shows an antioxidant that keeps asphalt from aging at the rate that it normally does. And if you can slow down the aging process, then you can slow down the cracking in pavements. We've got Hamid and Bainam here working diligently, I see, putting on fixtures on asphalt mix specimens. Sometimes we just have to invent a new test, and this universal test machine that you see here can test at high temperatures, low temperatures, high speed, low speed, and all sorts of shapes. We can do indirect tension testing using this Brazilian split tensile fixture that you see here. We can test in uniaxial mode on a cylinder. We can do cyclic uniaxial testing at high strain, low strain. We can even fatigue asphalt over the course of a month to characterize it for the long-term durabilities. This is one of 4 laboratories. This is our showcase lab of Maple, but Maple extends to other laboratories that can test wheel path rutting of asphalt, so we can test its high temperature durability and its resistance to moisture. And so that's a little bit about the Maple Laboratory, and last thing I'd like to say is you're welcome to visit the Maple Lab at any time, so we hope to see you here sometime soon in sunny old Columbia, Missouri. Thanks.